Hello everybody, Sean from SMD Methods back here again. You're very welcome into the sixth video on this series on setting up a Siemens ET200 PLC with a template from which a solution for a PLC task is outlined in the regional qualifiers of the automation discipline of World Skills can be derived. So in the last video we created the sequences. We created a sequence 1 and then we copied that to create a sequence 2. In this video, we're going to move on to the last major function block or function call that's required in this template. Again, you know, as you do maybe further develop this template for a more involved template to focus in on national finals, for instance. You will be adding in more functions, you know, for various sections of PLC coding and this and that. But the main ones here are the ones that are required to solve task C's of the regional qualifiers using this method, my method here of this kind of modular method of solving these PLC tasks. So what I'm going to do now is I'm going to add on a new block. Again, it's a function. SCL is the language, of course, we're coding in. And this one I'm going to call it MGMT. All right, management. And what I'm going to do here as well is, there's, I'm going to minimize this. As you can imagine, these templates evolve all the time. So in one World Skills cycle, which generally run from March till November, for teams I train, I could go through nearly 12 templates in that time. So it's nearly every couple of weeks that we're meeting. I say, ladies and gents, scrap the old template. Here's a new template. It has additional functionality for this and that. It's easier to navigate this way and that way. So what I'm given here is kind of the most recent template I had for regionals that didn't undertake further development for national finals. So this is roughly about 1 year old. Now, one of the changes that I have made in that time, obviously I won't show you all the changes I made. You know, we'll try to maintain some sort of competitive advantage. But one of the changes I've made, I may as well just add it in now, is in the PLC tags. Okay, you can do it in any one of these, or you can do it in more than one. I'm going to do it here in one of them here. See, in the UDT sequence, right? I'm going to go down to counters. I'm going to add in a new row, right? And I'm just going to call this proxy bit, and it is a Boolean bit. All right, that's all. I'm just going to add in proxy bit there. Excuse me, and you just prefix that with a small x. Control C. I'm going to copy that. I'm going to X that. I'm going to come into management. I'm going to add in this row, and I'm going to paste that in there, proxy bit as well. Now, what that is a Boolean piece of Boolean data that I'm just going to use as a placeholder. So where we would have seen it, I'll actually just show it to you maybe here instead of trying to explain it. Obviously, we changed UDT, so we've changed the fundamental structure of the code, so we must compile. And a lot of the times here, usually when you add in a structure, it's more prevalent, but the odd time, whenever you update these, like now, we'll still have an error on the network. So even hitting onto network 2 and hitting compile isn't going to change anything. What this has done is it's lost its way to the data source. So I'm just going to redefine this again. My data sequence 1 and my data sequence 2, and of course my data sequence 3. All right. Now, safety independence is going to be the same thing. Now, bearing in mind, right, you have to delete these and then rewrite them again, because if I just overwrite them, it isn't going to work. So for instance, that's my data sequence 1. If I just try to overwrite it again, my data, that's sequence 1, the error is going to remain. There it is. All right. I'm not 100% clear on why this happens sometimes when you compile after changing the UDT, and other times it doesn't. Maybe someone might come in and explain it to me. And number two, why it is that they have to be deleted so I can reassociate them as opposed to them reassociating by the overwritten text entry. But there you have it. Sometimes it's as important, if not more important, to know how to fix these things. It's not more important to know how to fix them than to know what causes them. Obviously, it's most important to know what causes them so you can avoid it, but it's most important there to be able to fix them after a debug. Anyway, so the two of them bits are in. So what do they do? Okay, if I come back in here now to sequence one, so you notice there in sequence one, I didn't lose it there. It only happened in the outputs. There you have it. In sequence one, if you recall, shoot this up. In counters, I put in DI spare, right? DI spare here. So if you missed this, it's in the last video. It'll be for going into it. Whenever we wrote our counters, we said that I want my increment, my count up increment to occur whenever my sequence step is equal to the step that I've indicated in my data block for this counter. And also when I see some input. So what is that some input? That some input I put in as DI X spare, the first spare input I have. But it's not what I want to use in this one here. What I'm going to do is I'm going to put this one in here as sequence data.proxy, or .dx proxy bit. All right. So I've again freed up that data bit again. Now, you don't have to do this, but the thing about it is that you might want to, you could leave in something like this here, look, some input, because I don't know what the input is. This is going to be code specific, right? You can't write a template here that's going to know exactly what input your counter is going to increment on, right? You're going to have to update that. If I put in some input here and it doesn't see that, parameter up here or script variable, you're going to have this error and you will not be able to compile. And if you can't compile, you won't be able to download it into your PLC. And if you can't download it into your PLC, you do not have a template sitting on your PLC when competition time starts. So you need to be able to make sure that you can download into the PLC, and a prerequisite of that is being able to compile. So I need something that I can see. And I'm writing sequence one here. So what I'm going to use is the sequence data proxy bit. Sequence data proxy bit. Now I could have left it, as I said, I can make that LOA if I want, LOB, whatever I want. But if I see proxy bit in there, and I can keep them all the same, doesn't matter. There's nothing to switch it on and off. It just sits there, and it's provision that I have in to allow me to compile. All right, proxy bit is not linked in the CP block to anything, so there's nothing going to fire this on and off. It's just sitting there. If your counter's not working, it's probably because you forgot there to update your proxy bit to what it should be, which might be LOA, LOB, L1B, L1C, whatever it may be. Okay, so we only put in 4 counters in each of our sequences, and that's what that's in for, proxy bit. Now that's sequence 1. Just for the sake of completeness on this, I'm going to do it for sequence 2 as well, so please bear with me. I had considered just saying, look, don't forget to do sequence 2 and park it, but I'm not. I'm just going to do it for the sake of making sure everything I have done is correct and there's no comebacks on it. Proxy bit, take that off. That's them all done now. Now, what prompted me to come back and do that? Why didn't I do that yesterday? Well, I wasn't going to do it with these or not yesterday in the last video. I wasn't going to do it there because the other thing will work. You know, just leaving in some input, DI, some input. Once it's once it's up here in the sequence data or it's in DI or wherever it may be, that's the one we were using there. Once it's there, it's fine. This is the one we're now using there. But in the management block that we just created and we're going to populate now, it's more frequent to have to need some sort of a placeholder in here. Let's go on into the management block. So in out, I want to be able to read write to management, specifically write out to that. I'm gonna want, I'll go for sequences first. I want to be able to see what's happening in sequence 1. UDT sequence. I want to see what's in sequence 2. UDT sequence. I'm going to go for sequence 3 because I'll probably end up creating a third sequence after this. We'll finish the management block. DI. I want to know what's happening to the DIs. That's UDT DI. And of course DQ. So each one of my UDTs has visibility in the management block. Okay, so that's that. So the I'm going to do up here in the first place is I'm going to put in a region here for timers. Statement for the region. Now I'm going to the code management timers, code MGMT timers. So EG, hold button in for 3 seconds to start a sequence. Right? So we've all seen that before. Sequence should not start unless you hold in the second push button or a momentary push button for 3 seconds. Well, how do you think you get to 3 seconds? Well, what we're going to do is we're going to increment this here on a timer for 3 seconds. Okay, so let's go for timer 1. Put in 2 timers here, and of course we're coding the management timers. Management dot timers dot timer 1 function. So we're only doing the functions here. These do not have steps because there's no steps in management. Right. Function timer. Let me just dot timer 1 function TON. Don't even need the TON in that, I don't think. Function. Pardon me. Timers dot timer 1 function. We can put in that TON. Not really required, but input, right? So what is going to be the input on this? I'm going to say the input is just going to be, again, a management dot x proxy bit. All right. Now you're obviously going to change that to be PB2 or PB3 or PB4, whatever you want that timer to be. All right. And then of course our PT, preset time on this, is going to be equal to whatever is going to be programmed in the the PT variable in management dot timers dot timer 1 function dot PT. That's it done. So there's that one done, and we'll do. I'll tell you what, we'll not even write in another one. I haven't seen one yet where you hold in, say, the first momentary push button for 3 seconds to start sequence 1, the second momentary push button in for 3 seconds to start sequence 2. I haven't seen that before. There's nothing to say that it won't be there, but if it is, you've seen it in the sequence block, you know how to do it. You copy and paste this, and there'll be 1 to change, 2 to change, and 3 to change. There's only 3 changes to making it. All right, so there's timers. Okay, so now what we're going to do is we're going to move on and we're going to code the counters. So what we'll do is put in another region. We'll only code one counter as we did here with the timers above. Counters. So this is going to be code management counters, e.g. Press a PB push button 3 times to start a sequence. Alright, let me just check what I did up here in timers to start a seconds, e.g. hold. Code management timers, code management counters. Alright, so let's go for CNTR1, counter 1. These here are in management. These are the management counters, management.counters. Counter function 1. This is a CTU. Open up a brackets. My CU, my count up value, is going to be equal to, I'm going to put this in here as my X proxy bit, excuse me, management.X proxy bit. Now, that's something you're going to change. Obviously, X proxy bit might be changed to PB2, might be changed to PB3, whatever it may be. It's just something you're going to have to evaluate and assess what the change needs to be, again, depending on what the sequence requirements ask for. Next thing I'm going to do is I'm going to put in a reset. Now, reset you need to be careful of. Reset is going to be very dependent on what follows this counter. So whenever the counter has elapsed, whenever the amount of increments that you are counting has matched the preset value that you've put in, the PV that you've put in, something's going to happen. So a couple of steps after that thing happens, you're going to use that to reset. So it could be anything. Now, I'm going to put in a reset here for this template based off of what counters in management are usually used for, which is starting a sequence. So for instance, press a button 3 times, I start sequence 1. So I'm going to put in my reset there to be some event that happens in sequence 1. Now, how many steps down? I always use 2 steps down. So after the counter, the first thing that happens is I move into sequence 1, say, right? But I don't count that as a step because it's nearly instantaneous, right? The first step in that is I'm going to move from step 0 to 10, and the second step is when I move to step 10 to 20. So when I'm in step 20 of sequence 1, I've carried out 2 steps subsequent to the sequence definition or the sequence specification. So the reset is going to be whenever I'm in sequence 1 dot W step is equal to 20. Now, again, you're going to have to change that depending on what your counter does. Right? This is just an example for here. To start, I'll actually change that to start sequence 1 in this case specifically. If it's start sequence 2, obviously you're going to make that sequence 2 step. Right? And then the next thing is, what is my preset value for this counter is going to be what I have entered into my data block. My data counters or management counters dot function 1 dot preset value PV. Close bracket, semicolon to execute. That's it. Now, again, I can do a counter, copy and paste that, put that in for counter 2 or whatever, but I'm not going to do that. Again, just in the interest of keeping this video to a reasonable length, and that we've already seen how to do that in sequence 1. Right? You just copy and paste and make sure that you change all your 1s to 2s to represent that you're changing to the second counter. And like the timers, I believe you only have 3 changes to make in this. You'll have counter 1 there, 2, and 3. 3 changes to make. Okay. Now the next thing what I'm going to do in this one here is I'm going to put in a region for safe status. Now, this is going to be developed. Now, this has to be developed, but for the sake of the regional competition, all we need to do is say that the system is safe or it's not safe. Okay. What makes it safe or unsafe will be development for national finals, and what happens when it becomes unsafe, is development for national finals. For regionals, possibly not so much. Okay, but for here, safe status, we're either going to be safe or unsafe. So what I'm going to do here now, okay, this is just what we're going to, if you just watch this one now. Okay, so I'm going to write if. Now I'm going to write in here, this is going to be system is safe. This is the conditions for system is safe. If I have di dot say my safety light, when we go up to my e-stop first, I'll do the e-stop first. Where's my e-stop? There's e-stop. If di e-stop and di dot safety light curtain, then management dot safe status is equal to safe. Oh, single quotes, apologies, in TAA, semicolon. Now, I'm just going to write it in as else it's unsafe. Now, obviously, this is where the development comes in, because it might be an else if, and I might have more than safe or unsafe. And if. All right, so that's all I'm going to write in there. Now at the minute, my e-stop and safety light curtain inputs are going to be false, going to be low, so my system is going to be in an unsafe mode, and if it's in an unsafe mode, I'm not going to be able to access all my outputs, because in my main block, if you can recall from an earlier video, the access here to these safety dependent outputs depends on the system safe status being safe. All right, so we'll put in provision to change that just now, just to let us away for the template. All right, so let's X that down. Let's come back into the management. Right, now the next thing what I'm going to do here is I'm going to put in a region, right, and I'm going to put in first scan. What happens at first scan? All right, so if first scan is going to be percentage sign M1 dot 0. If M1 dot 0, so if I'm at first scan, then what do you want to happen? Well, I want to make sure that everything gets returned to zero state. So this is going to be a fairly, not so much a lengthy process, but I just want to say the first time I turn on my PLCs, I just want to make sure everything is at its starting place with respect to what sequence I'm running, what modes I'm running, what my counter values are, what my step values are, and so on. So this can get fairly long, okay? So I'm not going to write it all out, but hopefully you'll get the gist of what I'm doing here. All right. So the first thing is I want to write is that I want to be management.run mode is equal to 0. Now that might change. I might want to start this in a diagnostic mode first. So run mode for me is that I'm in standby. Everything's hunky-dory. You're just sitting there waiting to be put into a mode. All right. Run mode 9 is usually for me an emergency mode. Some sort of an emergency state. So I'm going to be unsafe. Being unsafe will trigger some mode that's in the 9s, 9.1, 9.2, 9.3, which means maybe an e-stop is pressed, or the light curtain's pressed, or door interlocks open or something. Okay, mode 6 is generally a recovery mode. All right, so after I've come out of an emergency state, I've hit a reset button, nothing's happened, I might want to reinitialize or do a diagnostics check or do something. I'll use a different mode for that. All right, so I just want to put management mode is equal to 0. So everything's just on standby. I want to say that I'm not running any sequences at all. Sequence is equal to 0. Right. Now, normally what I'll do in here is I will put in my sequence stuff. I want to put all my sequence steps back to 0, just in case that for some reason power went down or I lost access to a block or this or that. Sequence 1.w step, I'm going to set that equal to 0. And I'll do the same then for sequence 2 and 3. And if I had more than that sequence-wise, I would also add them into there as well. All right. Now, another thing that you might want to do in this is you might want to reset all your counters and all your sequences, all right, which will start to get fairly heavy there as well. So I'm not going to put all them in, but you might want, you just want to reset everything back to 0. All right, so I'm just going to leave it at that for now. It's adequate for a template. All right, that's what happens at first scan. Now, past the first scan, the next thing that I want to do is I want to put in what I call initial conditions. And these are the states of my output actuator. So sometimes cylinder A might start extended, or B might start extended, or whatever. Right. So I'm going to set the states of the actuators when in standby. So I'm going to say if, and we can put this in, use this as a mode or a sequence. I generally will use this as a sequence. So if management dot run sequence is equal to 0, so then, right, if the management runs, so if I'm not running any sequence, right, so when I first turn on, I first scan, I'm going to put myself into 0. What should my actuators do? So imagine all my actuators are retracted here, the solenoids aren't on. I turn on my PLC, and if I want them both to be extended, right, I want to make sure that I fire the 14 solenoid on the DCV for A and on B. Okay, if I want them both retracted, I want to make sure I fire on the 12 solenoid for A and B, the DCVs for them to make sure that they are retracted. Could be a case there in the night shift comes in, or maybe cleaners come in the evening and they pull out a rod and are cleaning or whatever, and they leave it. When you come in the morning there, you want to make sure that these start where they should. So I'm going to just assume that everything's going to start in its retracted state. So if management run sequence is equal to 0, then dq dot a extend, the extend for A is going to be false. dq dot b extend is equal to false, and of course dq dot c extend is equal to false. These are the only ones that I have now at the minute. Right, so it's not only there that it's good enough to say that we do not turn on the solenoids to extend these, but we do also want to turn on the solenoids to retract them, just in case that they are extended. So all my EXTs, I'm just going to change them to rets, and all my falses, be ret, I'm going to change to true. C ret, apologies, just would have been quicker in hindsight to write them. All right, true. True and true. Grand. So that means A extend should be false, but A retract should be true. B extend should be false, but B retract should be true. C extend should be false, C retract should be true. And end if. Now, before I make my next change onto my block here, come on, I don't know yet. All right. Before I make my or add in my next bit here, let's see for scan. What have I missed there? I missed an end if there. That's why it didn't indent correctly below. All right. I want to make one more change here before I put on the next region into management, because the initial conditions are going to operate here. Right? I'm A extend to be false, A retract to be true when I'm in 0. Right? Whenever I look into my safety dependent outputs, right, these are also instructions for what should happen to my actuators as well. I don't want to make sure that I'm giving conflicting instructions to the actuators. My management here telling it to do one thing, and my my output block itself telling it to do something different. So what I'm going to do is I'm going to go to my safety dependent ones here, which are this, and I'm going to make sure that I can only access this output block when I'm not in sequence 0. Because in sequence 0, I'm going to let the management say what the output should do. All right, the management is definitely going to say what the outputs are going to do in here. So what I want to write in here is I'm going to put in another comparator block. Right, I'm going to use a comparator here, then I'm going to say only let it through so long as I'm not equal to 0. This one here is going to look at my data dot management dot run sequence and then put in 0. So long as I'm not equal to 0, you can use the code that's in here. But if I am equal to 0, if I'm not running any sequence at all, right, management here is going to set the tone for what these actuators are doing. So I hope that makes sense. Okay, the next one we're going to put in here is kind of the mainstay ones. Is our modes and our sequences, how we run our separate modes and how we run our sequences. So I normally write these up here with the first by doing sequences. And the way these get set up is what you do at the end of a sequence, okay, and then how you get into the sequence, right? There's really going to be that sort of order of operation in it, right? It's what happens at the end of a sequence, and then what happens at the how I start a sequence, right? So let me just change that to end of sequence, and just leave it end of sequence. So we're going to do sequence 1 first. End of, say, let me just put it this way. Put in a sub, I'll actually do this here with the sub-region sequences, put in another region. Let's do sequence 1. Let's put this one here as end. Put in code sequences. And put in 3 number here, just for now. Region for sequence 1, end of sequence. Right, so for sequence 1, what happens at the end of sequence? I'm just going to say if management dot run sequence is equal to 1, and so if I'm equal to 1, if I am running sequence 1 and sequence 1 dot x complete and I'm complete, then what do you want to happen? What happens there whenever you finish off running sequence 1? Right. What I'm going to do here for me is I'm going to put myself back into management dot run sequence. I'm going to set that equal to 0. I'm going to go back to standby. Now, a couple more things to add into that, but I just want to talk you through this here. So if you recall here from sequence 1, at the very end of the sequence, we said that the sequence x complete is equal to true. That's it. We don't put our steps back to 0. We say that the sequence complete is equal to 0. Or it's true. Apologies. So here I'm saying if I run sequence 1 and sequence 1 is complete, then the management run sequence is equal to 0. All right. So if I'm now running equal to 0, again, I can no longer access my outputs, right? I can now no longer access sequence 1 itself, because by virtue of the fact main sequence or sequence 1 can only be accessed when I'm equal to 1. So the first thing I want to do is I want to lock myself out of sequence 1 by putting myself back to sequence 0. The next thing there that I want to do is I want to put my step back to 0. Apologies, sequence 1.w step. Then I'm going to set that equal to 0. And then last thing I'm going to do is I'm going to say that sequence 1x complete is equal to false. I'm going to reset my complete flag. Full stop. That's it. Them 3 things are going to happen at the end. All right, so that's what happens there. Code 3 sequence, reading sequence 1, end of sequence, and if. Next section is going to be to start the sequence. All right, so to start the sequence, if. Right. Now, this is a way I do it here that's different from a lot. I also use run modes. All right, there's a wee bit of getting your head around it. It has a huge amount of advantages if you can get your head around doing it. We could do something very easy for start the sequence. So for instance, right, we could say that if management dot run sequence is equal to 0 if I'm in standby, right, and say di dot xpv1 or xpv2, sorry, xpv2, then management dot run sequence is equal to 1. That'll work. So if I'm equal to 0, as I would be here, and I press PV2, then I set PV1 equal to 1. If I set my run sequence equal to 1, I'll access this block. It'll come in. It'll say, well, if I'm equal to 0, which I am because I reset it to 0, if I'm not complete, which I'm not, and if my two cylinders are back, A and B are both back, then go on to 10 and I'm away. That will work absolutely brilliantly in management, but I lose a little bit of functionality with that, because what if it's a case there that I want to put the system on to standby? I want to run it. Maybe I want to run a couple of sequences, one after the other. So say sequence 1 is say ABBA. Sequence 2 is say CDDC. But sequence 3 is ABBA CDDC, is what was sequence 1 and then sequence 2 together. I like to think of more of modes. So if I press push button 2, I'm into mode 1, and in mode 1 I'm going to run a sequence, or maybe I'll run 2 sequences, maybe I'll run 1 sequence and stop. Whereas in mode 3 I might run 2 sequences, one after the other, and then stop. Maybe in mode 4 I might repeat a sequence forever until I hit a separate stop button. So I bring in a mode there to instruct the PLC on which sequences to execute and what order to execute them in. Okay, so I'm going to do this template like that, and then we'll set it up in that manner with a couple of examples. So to start the sequence, absolutely, I need to be in run sequence 0, but I also want to be in this case, right, with management.run mode, I'm going to say is equal to 1. So if management run mode is equal to 1 and management run sequence is equal to 0, right, then I'm gonna and I press XPB2, then I'm going to run sequence 1. What I'm going to do is I'm going to take out XPB2 here. I'll show you why now in a second. Let's leave it at that. Sequence 1. Right. I'm going to Control C, paste it in here. Control C, Control V. I'm going to change this to sequence 2. If management is equal to sequence 2 and sequence 2 is complete, then management run sequence equal to 0. My sequence 2 step is 0 and my sequence 2 X complete false. If management run mode is equal to 1, I'm going to change this to 2. Again, this is just a template. These can be changed about. And management run sequence equal to 0. I'm not running any sequence. Then run for me sequence 2. So in mode 2, I'm going to run sequence 2. Okay, and then finally, I'm going to set up for sequence 3 here as well. Control C, Control V, sequence 3, management run sequence at the end. If I'm equal to 3 and sequence 3 is complete, that flag, for want of a much better description, is complete. It's true. Then put me back into sequence 0, reset my sequence 3 step, because I've been executing sequence 3, reset the step back to 0, and reset this again, for want of a better noun, this flag to false. So how do you start sequence 3? Well, I'm going to say if I make equal to run mode is equal to 3, and I'm not running any sequence, then go on ahead and run sequence 3. So in run mode, I'm running sequence 1. In run mode 2, I'm running sequence 2. Run mode 3, I'm running sequence 3. Maybe in run mode 4, I'm going to run sequence 1 and then sequence 2 and then sequence 3. So this is very general here now at the minute. That's it. So there's the region for the sequences. Now the final region, oh, I shouldn't have done that, region is the modes. So in order to run any sequence here, I need to first be in a mode. Right, so code modes. So in a minute I'm going to code 3 modes. Right, we know here at the end of any of these sequences, sorry there, I just shot over to switch on the light. Yeah, back onto the modes here. So the idea in this one here in the modes is that we're not going to say what happens at the end of the modes the way we have done this in the sequences, end of a sequence, start of a sequence. All we really want to do is we want to say how to start a mode. How do we get into a mode? Right. The ends of the modes will normally correspond with the endings of the sequences. So for coding the modes, right, what we'll do is we'll do mode 1. So I'll do this the same as I've done with the sequence by putting this into subregions. So this is going to be mode 1. Let's see, I thought I named mode 1. And at this section, excuse me, let's say starting the mode, or going into the mode. So if management dot run mode is equal to 0, and now I'm going to say that I'm going to hit a PB here, and di dot x PB2, then management run mode is equal to 1. Now again, these here are is set equal to 1. These here are going to be very particular to the code itself. It's going to be very particular to the code itself here. How you're going to get into the mode, and what mode you're going to run. But the important bit is here is that all we need to code in these sections is how you start the mode. Don't worry about getting out of the mode, because we're going to make an adjustment up here to the sequences to show that. All right, so there's region for mode 1, Control C. This is going to be for mode 2, starting the mode. So if I'm equal to 0 and say push button 3, then run mode 2. And finally, mode 3, if I'm in mode 0 and I press push button 4, the last one for instance, then run mode 3. All right, so there's the 3 modes in there in the mode section. Let's to keep the spacing the same as above. Sequences, region sequence 1, the way it's when they wrote it up that road like that, just put it on seq 1. Seq 2. Just trying to keep it the same as how I have wrote it in the modes. Seq 3. All right, now one final thing now, just to update based on this. Right, so this is where all the action really happens in here. So if we can imagine that the PLC is scanning this function up and down, it comes to sequences, and it's going to check each one of these. It says, oh, are you going to sequence 1? No. So I'm not going to scan that. Am I equal to management run mode 1? No. So I'm not going to scan that. Go on to sequence 2. Am I going to sequence 2? No, I'm not going to scan that. Mode 2? No, I'm not going to scan that. into here, sequence 3, no, don't scan that, that's not true, go out of it. Now it comes into 4, mode 1, and my run mode is equal to 0, yeah, it is equal to 0. And then it's going to keep on scanning here and looking and waiting for PB2 in this case, waiting for PB3 in this one, and waiting in PB4 for this one here. But at some stage, imagine I hit PB2, and one scan through this, it's going to say management run mode is equal to 0 and PB2. Oh, I see that. Okay, management run mode is now equal to 1. So it goes up to the top and starts scanning again and looks in here. If management run sequence equal to 1, it is, and sequence 1 is complete, then all this. Well, sequence 1 is not complete, so I'm not doing any of this. However, management run mode is equal to 1, yes, and management run sequence is equal to 0, which that is true, then run sequence 1. So what actually I'm going to do in here is I'm going to put in another and here, and I'll say and not sequence 1 complete. I don't really need to put it in here because that is one of the primary conditions of sequence 1 itself to actually start. You'll see it there, and not sequence 1 complete. Right? But what I'll do is we can put it out here as well, just and not sequence 1 complete. And sequence, not sequence data, but sequence 1 when it's in this block. And my run sequence is equal to 0. So if I make it the 1 and sequence complete, sequence 1x, I'll tell you what, I'm not going to put that in there. Sorry for putting it back and forth. I don't really need to. I'm going to keep it just the way it is. I don't want to overcomplicate it. Management run mode, I put management run mode into 1 by pressing the button. I'm not running any sequence at all, or then going ahead and run sequence 1, because I'm going to run sequence 1 whenever run mode is equal to 1. That's why. So now run mode is going to be equal to 1, and I'm going to run all of that. And then when run mode, when sequence 1 is complete, this condition is going to be true. I still will be in sequence 1, and I'm going to be complete. So the first thing it's going to do is going to kick me back out to 0. It's going to reset my step, and it's going to reset my sequence complete flag. All right, and that puts me back onto square 1 again. All right. Now, the only thing that it doesn't do at the end of the sequence, actually, is that I am still in run mode 1 here. Right? At the end of the sequence, I'm still in run mode 1, and management run sequence will be equal to 0. So it's just going to kick me back in. So what I also need to do is I need to put management run mode back to be 0 itself. I need to move back out of 0 for this particular case. All right? So if this all happens, the run sequence here is going to be equal to 0. But what I'm going to do is I'm going to put another layer separation into that. I'm going to put that equal to 1 or equal to 0 on that. So I'm going to put my management run mode back to standby, run sequence to 0, put my step back to 0, and reset my sequence complete flag. So I'm going to copy this line of code here and put that into sequence 2 as well at the end of the sequence. Put my run mode back to 0, and here run mode goes to 0 as well. Now, it seems to be an additional layer for very little gain on this one here when I could just plain run the sequence. Yeah, that is true, but you have an awful lot more functionality if you do run with what I call a mode and then a sequence, because you can run multiple sequences in any given mode. All right, so we'll see about looking at an example or two of that. So that's it. That's the management block. Other than that, other couple of things that I commonly will have in this one here would be the likes of the coding for the rise and edge detections. I'd put in the coding there as well for the what happens when I hit e-stop. And what happens there, say when the safety light curtain gets broken and so on, all them wee bits there will also tend to get added in. What you could also do in this one here is put in say for sequence 0, what happens when you're in sequence 0, or put in like a get into sequence 0 shortcut. You know, if the code gets hung up or the execution stalls for whatever reason, you want to force it back into 0. You know, there's other wee bits that you could put in, but for the most part, there's enough in this one here to get you through the regional qualifiers. You know, fairly efficiently. So I'm going to finish up this video, but in the next one, what we'll do is we'll look at the regional qualifiers for the last few years. We'll do one per video, discuss them, see how the template fits them, and yeah, see how that they'll work for you as well. So again, I hope you took a little bit out of this video. Maybe you've seen a couple of things that you haven't seen before with respect to setting up functions and setting up blocks and how these interface. But actually, before I do that, speaking about interfacing, I need to obviously bring this this call into the networks here. So what I'll do is I'm going to select network 1 on this one here. I'm going to add in a new network for network 2. I tend to put management into network 2. Apologies for that. I was getting ahead of myself looking to get out of this video earlier than I should have been. My data management, sequence 1, my data seq 1, my data seq 2, my data seq 3, my data DI, and my data DQ. All right, it's the management block, and what I'm going to do as well, I said I would do it at the start, is I'm going to Control C, Control V, sequence 2, F2, rename that 3, make a sequence 3 out of that, sequence 2 network, right? Control C, Control V, network 7, I'm going to change to 3, and change the name of this here till 3. Doesn't look much like a 3. There it is. And I'm going to change this to 3 for access, and I'm going to address sequence data from that function to my data sequence 3. Now there's a third sequence in it. Let's get rid of 8 and 9. And let's try a compile. 0 errors, 0 warnings. Everything looks hunky-dory. Let's save that. And yeah, that's a template done for a regional qualifier for automation. So building on the Festo didactic edu learner, the learning kit, the rig, the profile plate with TP101, TP201, and TP202. And any other sort of hardware that they might give you as well. So yeah, I hope you took a wee bit away from the video. Let me know again, as always, in the comments. Do hit the subscribe button on this, because I'd like to push these forward, obviously, into national finals as well. I have trained the SRC team for the last 5 years. We've had great success in World Skills, so these templates do work very well. I'm not taking a team this year, so I will be pushing more content in to try to plug the gap some other way. In all them hours that I would otherwise be training teams in. So yeah, definitely hit the subscribe button, because as I release these, you'll get to pick them up and hopefully apply them for your own progression in the competition. And I do hope that they help you progress and code better in a very structured, kind of very important, scalable manner, and relatively easily navigable manner. You know how to find your way around the code. Okay, so thanks again, and I'll see you in the next video when we apply this to a task. Thank you.